I'm Dr. Ralph Ford, Chancellor of Penn State Behrend, and you are listening to Behrend Talks. My guest today is Julia Cecchetti, a Behrend graduate who now works as a senior propulsion engineer with Impulse Space. Julia lives and works in California, but she's back at Behrend today for a very special reason, meeting with students, faculty, staff. I had a lecture earlier today, but the reason why is you are one of 10 prominent young Penn State alumni. That's across the whole university. And you're going to be honored tomorrow in State College with the Alumni Achievement Award. I'll be there as well. We love when you come back to campus first and you talk to people. But congratulations, Julia. Welcome to Behrend Talks.
Thank you very much.
Well, let's begin with a little bit about you. So I'm going to run through some of the highlights of your career. You earned a degree in mechanical engineering here in 2020. By the way, that was the COVID year. So you were that class that we all sat, that horrible time, and you got your degree electronically. It was kind of a terrible time.
Yeah, I watched my graduation from my couch in pajamas.
But you got it was like that March, so you got pretty close by the time you were here. Most of your time here was in person. But you graduated after only 2 years full-time here at Penn State Behrend. We're going to talk about that, how you managed to do that. While you were here, you secured internships at GE Transportation, SpaceX, where you worked on something known as the Dragon, a reusable spacecraft designed to carry crew and cargo to the International Space Station. In the years that followed, you worked on the Raptor engine and in a whole lot of other capacities, and you left SpaceX this last November for a job opportunity in a place called Impulse Space. And maybe some other stops along the way, but I think that's it in a nutshell.
That's correct.
Tell us, you work at a place called Impulse Space. What's Impulse Space do?
So Impulse Space is a startup. They are a company that is focusing on in-space mobility, so not necessarily the rocket launch part from the ground, but once the rocket is in space, focusing on getting from one orbit to another, going to geosynchronous orbit in as little as 1 day with a customer's payload, and also doing anything in space, out of the atmosphere, landers, different satellite buses for switching from one orbit to another.
So if you say geosynchronous, I heard you say 1 day. What's the significance? Like, what's it take now? I mean, there must be something new in what this company is thinking about.
Yeah, so usually it takes a long transfer period to get to geosynchronous orbit, and one of the things that Impulse is driving toward is providing a service that will get a customer's payload to geosynchronous in 1 day, like Amazon, like 1 day delivery, which really isn't a thing right now in the space industry.
So the rocket goes up and you meet it at some point, and then you switch the payload and take it from there in a way that the rocket that took off from Earth couldn't.
The payload would be already on. It's kind of like a third stage, or they would be already on Impulse's vehicle.
Okay. Well, you say startup. The other thing I noticed was they just raised, I think, like $300 million. It sounds like a pretty big startup operation.
Oh yeah, we have over 300 employees now.
And growing?
And growing, rapidly growing.
Went to your website and I saw like 130 job openings. It's like right on the front page. So you're trying to hire people. We'll talk about that because the myth is there are no jobs out there. Obviously, there are some jobs.
So many job openings.
Okay.
Please come work for us.
Well, why don't you explain to us, so help us understand. You're a propulsion engineer. What's your day look like? What do you do in that role each and every day?
Yeah, so I'm a propulsion engineer, so I am responsible for designing new rocket engine designs for Impulse Space. So expanding the family of engines that Impulse Space has to fill different niches and different needs, more on the higher thrust end of the rocket engines that we have currently. And so when I get into work, I'll either be designing the rocket in computer-aided design or CAD. Mm-hmm. I'll help with the manufacturing process, and then I'll take it out to the Mojave Desert and test fire it. So
really, you get to take it out to the Mojave Desert? Some sort of prototype, or is it a full-blown prototype of this?
Yeah, it's a working engine that go up to the Mojave, and I'll decide what tests we need to do, and we'll go try to fire the engine and see what data comes out of that and improve it from there.
Wow. Obviously, this isn't just like, hey, I decided I'm going tomorrow. There's a lot of planning into building one of those in, right? And I'm sure that they have a facility out there already, and you have to do a lot of planning just to get to that point.
Well, yeah, we have a facility, but one of the great things about being kind of a nimble startup culture is that there isn't so much paperwork or planning that needs to do to get time on the test stand. We are able to have test stands that we rapidly built to be able to support that. So being really nimble. And one day I did decide, oh, I need to go test this tomorrow. I'm going to drive up to Mojave.
And away you went. And did it work?
It did.
It did work. Some of them fail, though, right? I mean, fail fast is okay, too. That's probably part of the philosophy.
Yeah, that is.
Whenever there's a launch, whether it's a prototype or you've been involved in other launches, I mean, that sounds like a lot of pressure. And what's it like on launch day? Talk us through like some of the launches you've been through and some of the interesting things that have gone into space and the projects. We'd just love to hear some of those stories.
Yeah, launch day is always exciting. I compare it to the excitement I think some people feel when there's a football game and they're rooting for their team. It's just really exciting. You're seeing all of your hard work and your entire team's and company's hard work go onto the launch pad and go up. And it's also nerve-wracking. A lot of things can go wrong, but we also have a lot of confidence in it. It also depends on the rocket. Sometimes I've been involved in launches where we're launching a earlier prototype of something and also launches where we're launching people on a Dragon spacecraft. So it's definitely two different things. One was like, okay, well, it's a prototype and we're learning things. And the other one is saying, okay, we're confident. We are 100% confident here. And we've checked all of the boxes and crossed all of our T's and dotted all of our I's. And we're excited for the astronauts to go up and just watching the countdown. And we all gather around screens as long as we're not in mission control and just cheering on from the sidelines, looking at data and seeing everything go well.
So is this something you knew you always wanted to do? Was it like, you were a young kid and you thought you wanted to go into space, or did you just find it?
Well, I've always been interested in, I would say, rockets and space and NASA and stuff. And growing up, I wanted to work on the engines. I thought the rocket engines were just the neatest, coolest thing. And I saw the Apollo age and the Saturn V, and I thought, darn it, I missed the Apollo age.
Yep.
And now we're not really, the space shuttle just retired, and there's nothing really coming up. And I was kind of like bummed. I was like, oh man, well, I want to work on rockets. But then I saw SpaceX launching for the first couple times and thought that was really, really awesome. And then they landed a rocket, and I said, okay, I want to work there.
So
Yeah.
So you were in college at that time when you made that choice?
No, I was in early high school. I think it was like 2015.
Okay.
So I was a freshman in high school when they first landed the rocket. And all through high school, I kind of knew I wanted to work for SpaceX or some similar thing. I worked toward that. I did a lot of engineering extracurriculars and built robots, and just kind of from an early age really started to go toward engineering and started taking college classes here at Penn State Behrend.
You loved STEM. Yeah. You liked building things.
Oh,
right?
yeah.
You liked so. Well, I'm going to jump around here a little bit. Now, just go back to it. So I think what would be interesting for our listeners to understand is, what is the relationship between these space companies like Impulse Space and SpaceX and NASA? Are they competing? Are they working together? Is it a collaborative environment? And it's changed so much. It used to be, right, the federal government paid for NASA. We had the Apollo missions, but it's a very, very different world now.
I'd say it's very collaborative between Impulse, SpaceX, and NASA. I mean, Impulse rides on a Falcon 9 SpaceX rocket. So SpaceX provides the launch service and doesn't really provide the same things that Impulse is providing with the space mobility, and they're more focused on the launch side. So it's really more symbiotic and less competitive. And NASA is a customer of SpaceX, and the Dragon capsule is for NASA astronauts, and there's a really cooperative relationship there.
And really, there's enough business now with commercial partners who want to put payloads into space, whether they're doing a scientific experiment or whatever else it is, to drive the business for this as well? Mm-hmm. Or is that still emerging?
Yeah, it's definitely a growing business. The launch cost has come down so significantly that there are more and more things that are becoming commercially viable to go put into space with SpaceX's rideshare missions and lower launch costs.
So going back to the launches, I mean, you've obviously been involved with some launches that maybe, quote, weren't successful. I say weren't successful in that it didn't make it into space or it exploded. Is that true? And what's the feeling? But you probably knew that that was going to happen for some of those as well, too, right? That was part of the design, to try different designs and the like.
Yeah, so the philosophy is to rapidly build something and launch it with the knowledge that it might not work the first time, which is a very different than the NASA philosophy of, okay, let's spend 20 years and $3 billion designing something and then it has to work the first time. So it's a really different philosophy. And while it is hard to see the rocket not make it, you learn so much more from actually flying your hardware and seeing how it performed, seeing what really failed, because the things that you expect would cause the issue usually aren't. It's like if you know that it's going to be an issue, then you've done all the things to say, okay, we think this might be an issue, but we've done X, Y, and Z to try to mitigate that. And in my experience, it's usually not been the things that you expect. So it's really valuable to go fly it and
See it fail and
learn. I mean, you learn so much from a flight.
People don't like it, but you learn from failure.
You do, yeah.
So how do you balance innovation, reliability, and safety? And I mean, it gets to the point of this, because I've heard Elon Musk being interviewed, for example, where he talks about, well, we're going to take a whole different approach, where instead of over-engineering this part, if we could find a commercially available part, or if we could even find it at the hardware store, we're going to go do that and give it a try. Is that a real-life situation that you're in when you're designing these systems?
Definitely not for human spaceflight.
Okay, yep.
Don't want to
put you on the spot there.
There are two very different categories. There's the development of a new rocket, and then there's the human spaceflight and the commercial spaceflight that needs to be 100% reliable. And you're not putting hardware store bolts on that vehicle. Right. But yeah, the learn fast, fail hard, and continue to learn that way is, we call it new space, where there's a bunch of startups, including Impulse Space, and SpaceX is no longer a startup, but it kind of started this philosophy of don't be afraid to learn by churning through hardware. Just be hardware rich and go test things and learn.
How did that play in with your education here at Penn State Behrend as a mechanical engineer?
It's a good question. I would say it's definitely different. There's a lot of design work that goes into it, and I would say all the engineering classes are absolutely essential for being able to do the calculations and everything to design something that you think will work. And then beyond that, it is something that kind of learn in the industry where, okay, something failed. All of the assumptions were not necessarily known. Whereas on an exam, you have everything you need to solve the problem, and you don't really need to make too many assumptions. But in the industry, you don't necessarily know what the exact pressures or temperatures or everything is going to be. So you need to make a lot of assumptions. And that's really where I think the differences come in. But I think Penn State classes really prepare you for how do you make those assumptions and kind of getting an overall picture of the physics of the world and what matters.
It's so true. We don't know. I mean, in the academic world, we do work with a lot of uncertainty here. We try to bring that into the curriculum, but that's just it. You don't get perfect inputs. You don't have perfect amount of data to put everything together. What was your senior project, by the way?
My senior project was a little bit interesting in that I, as a personal project, started to design a liquid bipropellant rocket engine. So you just have a fuel and an oxidizer. You had liquid oxygen and alcohol. And I designed that as a fun side project, and I was asking all my professors a ton of questions in their office hours, unrelated to class, but related to, okay, how do I do the calculations for this heat transfer, and what assumptions could I make here? And they're like, what are you
doing?
And
what are you building? You got to let us know.
Yeah, and after I had designed it to a point where I thought I was ready to start building it, I asked my professors if they would do a design review, because I would make a presentation on, here's why I made all these assumptions, here's how I did the calculations, and here's my design. Please give me feedback on if you see a flaw or suggest another thing that I should go look into or calculate or see if it'll be a problem. And after that presentation, they said, wow, this is more work than a senior design project. And so I ended up kind of morphing that into my senior design project.
Good for you.
And then expanded that into doing all of the senior design project homework and research and stuff.
Did you bring someone else onto your team?
I did try to get a team, but rocket science sounds a little bit intimidating, so I wasn't able to get anybody else.
Now, you had an internship at SpaceX before that, is that correct? So
Yeah.
you'd already worked at SpaceX, and that got you thinking about this?
So I had started to design the engine slightly before that, and then I learned a ton of things at SpaceX about rocket engine design and how I was doing it wrong, and kind of completely redesigned it after that.
And how did you get the job at SpaceX?
So I said I wanted to, since high school, work at SpaceX. And I didn't really have an in, and I knew just sending my resume into the ether
Doesn't work.
doesn't necessarily work.
Maybe.
It can work sometimes, but it isn't a guarantee. But I also didn't really know anybody that had a connection. But I basically just asked everybody I knew, all the teachers and all of the parents' friends, do you know anybody that works there or used to work there? And was able to connect with somebody, and they sent my resume in.
Perfect. You were an early networker. You were fearless in networking, and that's how it
Definitely
works.
helps. Yeah, it definitely helps to have somebody refer you and to know somebody. But you don't need to know somebody from the beginning. You can find somebody.
I think that's fair enough. And I actually remember when I got out of college at one time, making some calls to people in the field just to see if I could find people. And it takes a little courage, but it can be done.
Yeah.
And it's interesting. People will almost always help you.
Oh, yeah.
Yeah. And what's the worst they can say? No? Right. Nothing lost. Let's go back to the beginning, your humble beginnings, kindergarten. And I understand that your parents taught you basic math using a novel method. And what was that?
My mom taught me addition and subtraction by putting out M&Ms and saying, okay, here's 5 M&Ms. What happens if you eat 3 M&Ms? And so I learned subtraction. I would get to eat the M&Ms that I would subtract, and then kind of learn that 5 minus 3 equals 2.
It's perfect, right? And
It was perfect,
By the
yeah.
way, for the record, your mom is here in the room and listening in, so this is perfect to tell this story this way. So yeah, did you have a favorite? Is it like peanut or just basic M&Ms, or is that a little?
I remember
little
them
too
being
much?
basic M&Ms, I think.
They're-
We're really going far back into the memory archives here.
Well, in high school, we'll keep going. We won't go through every bit of your upbringing, but you taught yourself algebra, trigonometry, calculus, and you actually tested out of those classes. Is that true?
Yeah, I ended up doing a chess club, just a after school chess club. It was with the math teacher, the calculus teacher. And I was just really interested in math, and I had read ahead, and I was asking him questions every day about trigonometry and eventually calculus. And eventually he said, "Hey, wait a minute, this is at the end of the Calc 1 class. Maybe you should test out of this." Because at the time I had just taken Algebra 1, and so there's Algebra 2 and trigonometry and calculus.
This didn't come out of the ether. You must have been reading textbooks or something.
Yeah, I read textbooks. Yeah.
Wow.
Yeah. Well, I like
Great-
math.
Yeah,
I
it's
was a
great
nerd.
dedication. Absolutely. And, the one that always vexed me in high school, I loved math as well. I'm an engineer, but geometry was a mystery to me, and all the proofs that were in it still to this day, but I understand some of it. But anyways, we digress a little bit. But then at some point, you're at Iroquois High School, and for listeners who don't know, that's just down the road, it turns out, from Behrend. And at some point, you get connected with us, and you start taking courses here while you're in high school.
Yeah. So as a result of successfully testing out of math, I kind of ran out of math at Iroquois. And my mom had a friend here, and she was able to connect me with Dr. Rutter, who is a math professor here.
Sure.
And it was a little bit earlier than was normally allowed. Usually you have to be a junior to come take classes in person at Behrend. So I was then a freshman. So it was a little bit beyond the current rules, so I had to get special permission. But he was at first a little skeptical, but then after meeting him, he was able to allow me to take classes a little bit earlier here. And I went into Calc 1 here.
And how did you do sitting in, you're in 10th grade, and you're sitting in classes with college students? Was that intimidating?
It was a little intimidating. I also always have looked really young for my age, and so at that time I looked like a little kid. But I didn't really mention how old I was. I just said I'm a sophomore. And then in the first day of class, maybe it was the second day, the professor announced, "And we have a 10th grader in our class today."
Oh, really?
And he just completely outed me, and everyone turns around and says, "What?"
That must have been a little bit, put you on the spot, but it seems like you did okay. You probably got, let me guess, an A in the class?
I did, yeah.
All right. So there you showed all the other students in the class. So perfect. And you were at Behrend, a lot of experiences, but I know you did some interesting things working with Professor Joe Paulette and maybe some undergraduate research and a robotic snake. So can you tell us what that was about?
Yeah, that was a really cool research project. Dr. Paulette was doing mathematical research into snake locomotion. There's lots of different ways that snakes can get around. They have serpentine motion, kind of like the regular slithering S-shaped motion. They have sidewinding, where a snake over sand will kind of step in a sideways motion. And just really interesting patterns. And we built a robotic snake and programmed it to kind of learn more about what different parameters are important in that sort of locomotion.
Nice. And do you still keep in touch with him by any chance?
I will be seeing him later today.
All right. Good. You know he's retiring this year.
I do, yeah.
Yeah, he's great. He impacted many, many lives while he was here. And you were also part of the SAE Super Mileage Vehicle Team. Mm-hmm. And I believe that was maybe like one of our most successful years ever when you were part of that team.
Yeah, we got 3,014 miles per gallon in the car. And when I say car, for someone who's never seen a super mileage car, think tricycle in a bullet-shaped shell that I, as a very short 5'1", rounded up small person, could barely fit inside.
And what I do recall is actually I remember a little bit about that, and it's not just because you were small, although we have to have small people drive. And I always tell people the same thing. Yeah, it's got a lot of miles, but it's really not a lot of comfort in that. But it was also the fact that you could drive it well, because that's key too, like the control and turning on. It's like a run and kill approach or something. So explain how that works to maximize the gas mileage. So you actually had to be a good driver. It wasn't just about you being 5'1".
Yeah, so there were several strategies and many ways that the car can lose energy. The key ones being aerodynamic resistance, so just pushing through the air, rolling resistance, which is a really big one, and there's kind of scrubbing when turning, so you kind of lose energy when turning, or like going over a pothole or something like that. And so the other side of the equation is the energy input, so the engine and the fuel that the engine is using. So on a normal car, you'll press the accelerator, and then when you're coasting, the engine will be idling at a low RPM, but that is just wasting gas. And when we're trying to go on singular grams of fuel for multiple miles, that is a terrible way to get good mileage. So what we would do is, the most efficient way to run an engine is to floor it, to run at high RPM. So we would start off where we would floor it, turn the engine off, accelerate up to maybe 40 miles an hour, and then turn the engine off and coast for an entire mile. And the track wasn't necessarily flat. There was a big hill. It was a semi-truck test track. And so we would burn the engine at the bottom of the hill and then just barely crest over the top and then coast all the way back down to the bottom of the hill, like all the way around the track back to the bottom of the hill. And that would be a way to minimize the amount of time that the engine was on and also maximize the efficiency while the engine was on.
So what was it like? Can you describe, was it a little scary being in there at times, or did it have its moments?
It was like being in a very hot coffin I had these little windows, and there was rules on how well you were able to see out the car and through the mirrors. And you had to be able to like identify the number of fingers somebody was holding up. And that is kind of a low bar for how well you should be able to see outside of a car. So it was very low visibility, so you really had to know the track. But one interesting thing was it made it a little bit like Mario Kart, because there was a pond in the middle of the track and there would be turtles that would be walking across. And the turtle would win if you would hit a turtle.
If you hit a turtle, it would take your car out. Now, and that's just the end of it. A tremendous amount of work goes in, and by the way, there's really not a whole lot of academic credit. The students just do this for the love of the competition. And there's mechanical design, there's all sorts of work that goes in, simulation work, thermodynamics, right? Did you do all that part of it too before you ever got into the car?
Yeah, there was aerodynamic simulations that we did for the car's shape, and we made the car out of carbon fiber. It was a carbon fiber monocoque, which just means there's no frame. It's completely like a carbon fiber body. Made the car really streamlined, and then designed every part of the car, including the steering mechanisms and the drivetrain, and the engine was we only had to use just the aluminum engine block of a certain I think it was an Anima, Briggs & Stratton Animal engine. So we basically took all the parts off the engine and then put a sleeve inside the bore. So we took down the volume of the engine significantly. We changed the stroke, we changed everything about the engine, machined down parts of it, and basically took it from a carburetor and a magneto to electronic fuel injection and really tuned the engine to a really high degree to get maximum fuel efficiency on a dynamometer.
Pretty amazing. Yeah. And built up, I would say I got to see it over many years. So just to see how the knowledge would transfer from one class to the next to the next. And the fuel injection was new as well, I recall. It was always carbureted engines until a certain point that they allowed fuel injection. Is that correct too, right?
I don't know what the exact history of that is, but I actually just visited the super mileage lab earlier today and got to meet some of the students, and they had forgotten some of the wisdom of,
what'd you tell them?
Well, they didn't realize that some of the specific tires that we used to use made a really big difference. There was a specific tire that was really invaluable in getting the rolling resistance down to a minimum, and they were just hanging on the shelf. They're like, oh yeah, we've never used those tires. I'm like, oh, that was the secret sauce.
Oh, did you? So you went over and told them?
I went over and told them.
You probably paid a lot for that tire too, right? It was, it was a very specialized tire, is my guess.
Yeah, it was a tire that was a part of the earlier competition. So it was like a tire that we had received from an earlier version of the competition. When you signed up for the competition, you got these tires.
You got them.
Yeah,
Okay.
but they don't do that anymore. So
all right. Well, let's talk a little bit about your time in your early career. So you leave here, Behrend, you leave at the midst of the pandemic, and you go to work. You went to SpaceX directly at that point, is that correct?
Yeah, so I actually, right after classes went online in March or April of 2020, I was already going to SpaceX for summer internship, and my boss messaged me, hey, how would you feel about online school from Texas? And so I actually ended up working part-time as an intern kind of while classes were still going on.
And you
remotely.
were in Texas.
Yeah, so I was in the Starbase, Texas.
That was a smart bet because, we all thought, remember, we'd be back in 2 weeks, if you remember those days. So.
This was after they had already announced that it was going to be, it was
going to be a little bit longer.
They had already announced that the rest of the semester was going to be online. And so I took the opportunity to go there and really gained a lot on that internship, and then continued the internship all the way through the fall semester while I was taking my senior classes.
Okay. And that was the last set of classes you had to take, was it?
Yeah. So I was almost there and then graduated in fall of 2020. It was a really weird way to end school. It didn't feel real. I took exams remotely and then it just kind of ended.
Yeah. I will say that was the worst of the worst at that time. I remember it well, but we won't relive COVID. We're going to talk about something really neat, which was you won the NASA Early Career Achievement Medal. Which recognizes, your work in engineering, design, testing, and analysis. Could you just talk a little bit about that? And when did you win that? That seems like a pretty big deal for someone to get early in their career.
Yeah, I got that in 2023, and it was a real honor. I got to go down to Houston to receive it. I worked on the Dragon capsule that takes NASA astronauts, so NASA awarded me with that medal for some work that I did to basically creatively instrument a Draco engine to investigate a certain problem that we needed to find the cause of.
I'm sure you can't go into a tremendous amount of design detail, but it sounds, and we know it was really important. I was looking at the photo of that earlier today, the picture there. And by the way, I've been to the Houston Space Flight Center because we have a lot of Penn Staters there and also Behrend graduates, and some of them have gone on to be space flight directors. And so we've got a pretty good history of people going into NASA and other places too. But you also have won now the Penn State Alumni Achievement Award, or at least officially you'll get it tomorrow. And you get to talk to students. So, the whole point of this is come back to campus, talk to students. What things do you think you've learned and what wisdom are you bringing back to campus?
I think the biggest wisdom, and I said this during my talk earlier today to the students, is while school here at Penn State is great and classes are great, you really don't get all of the things that you need to go have a successful career just from classes. And my biggest advice is go find some personal project, design project, or just a hobby even, but go build a model remote control airplane and learn about aerodynamics with the wings if you want to go into that, or build a robot, or go improve something around the house with an automated system. And just something that you take what you've learned in classes and go apply that to something real and tangible and lead your own project to help hone your skills and also show when you go to apply for a job, when you're in an interview, you can have something to talk about that you did above and beyond just going to school.
It makes such a difference. Build something, actually make it work with some complexity. It's not easy to do, but it's a lot of fun.
It's a lot of fun, and it's really interesting, and you learn so much that you don't expect that you would.
Well, I'm going to put you on the spot a little bit. What do you think your career looks like in the next 5-10 years? Do you have any specific goals, things you're trying to build, do?
I definitely hope to continue designing rocket engines. It's my favorite thing. I'm really excited that my career has brought me to get to design and build engines. And I really see myself kind of continuing down that path and really becoming a true expert in rocket propulsion such that I can touch more programs and be a resource for new engine designs and younger engineers coming up.
That's a great place to be, and it seems like this industry just continues to grow, and people talk about colonizing Mars and the like. You tell us, where do you think things are going in the future?
I think humanity is going to have an awesome future as a spacefaring species. I think that the way that things are going now, we're going to have colonies on the moon and Mars and mining asteroids. I don't know when that'll happen, but I think we're at the precipice of starting that soon.
We're getting close.
Yeah.
You think you'll see it in your lifetime?
Oh, yeah. Yeah, I hope to go to the moon in my lifetime.
Advice for our students. I saw, that 130 jobs or so that are advertised on your website. Is this a good place for people, graduates, to be looking? And if
Oh, yeah.
they can reach out to you. I don't want everybody reaching out to you. Only if they're Behrend students. They can reach out to you and get some advice.
For sure, yeah. Those 130 jobs include new grad jobs as well. It's not just for seasoned, experienced people from the industry. And it's really valuable to have new grads and fresh perspectives that come in. And I would say definitely make sure on your resume you've got some fun personal projects and extracurriculars and stuff that you can talk to and say, look what I did.
How about AI? What advice would you give our graduates? What should they know? What should their fluency be in AI right now?
I'd say it's definitely a helpful tool. And I'm glad that I went through school without AI there. I think that it can be you can just turn your brain off and have AI do things, but that's going to be a real problem, I think, if you're a student and you're just saying, oh, I can have AI write my paper for me. The point of writing a paper isn't to learn about writing papers. It's also to understand the topic that you're writing about and really that. And I think AI really, you can either use it to just kind of float by, or it's also an incredible teacher. If you ask it questions, you can have a conversation about it. And it's about anything, any technical project. It can help you really understand. If you're having problems with a homework problem, it can help you through that. And it also could just give you the answer, but it can be a tutor as well. And I think if used correctly, it can really boost a student's ability to go above and beyond and learn more than they otherwise would. But I also think it's an easy thing to just turn your brain off.
You've said it so well, and I like to say it's got to be your critical thought partner. And if you know how to use it, it really can, you can go back and forth. You can have it ask you hard questions. You can have it shoot holes in your reasoning and all of those things. But it's easy to use it as a crutch as well. But I will say, I've told my students, I taught senior design again this year, the ultimate test is when you have to stand in front of me and you don't have AI there. You have to be able to answer the question. But you use it in your daily work?
I do. I don't trust it as far as I can throw it, but for something like a critical calculation, I would not use AI for. But for something like a small coding project where I need to make a fancy plot in MATLAB, I'll use it for that. And it's really a cool tool for that. It is something that can multiply your efficiency. Instead of spending an hour writing some code, you can...
Your company, Impulse Space, is all right with AI usage?
It is to a certain
degree,
but obviously, like, with caution. No...
You can't put any intellectual property out there.
You definitely can't put any intellectual property on there, and there's certain laws around rocket technology that you can't, like the AI is not secure enough to actually handle that data.
Well, we are pretty much at the end of the show. Do you have any final words or anything that you would like to add?
No, this has been great. Thank you so much for having me.
Well, thanks for being here. This has been a great conversation. And again, this is Behrend Talks, and my guest today is Julia Cecchetti, and she has won the prestigious Penn State Alumni Achievement Award. What that means is actually young alumni, those who have done something really significant in their careers, age 35 and younger. And we love having you back on campus, bringing the wisdom here. And you've been involved in other ways too, so we want to keep you engaged. And good luck to you, and we'll see you in the future.
Thank you so much.